All right, welcome to day 16, last day of new stuff for the unit. Tomorrow we're going to be doing 2 review sheets. Well, one review sheet tomorrow, another one Friday, one on angles and one on segments, which we're going to talk about today. So just get into the lesson, just some review here. So I'd urge you to try these on your own, and then we can go over them. So pause it, try them, and then we'll take a look. All right, so on the first one, we have an inscribed angle. So the intersected arc, if you remember, is twice as big. So x is going to be equal to 2 times 29, which is going to be equal to 58 degrees. All right, the second one, we have angles intersecting inside the circle. Remember, that means they're the average of the 2 intercepted arcs. So 74 is going to equal the average of 62 plus x. So divide by 2. Cross multiply or multiply both sides by 2 to get 148. Okay, is equal to 62 plus x, and then just subtract the 62, and we'll go from there. So that's 6, borrowing is 86, and there's the measure of x. Letter C here, we have the same thing going on. So, well, remember the angles formed outside. Remember the saying outside is different, and difference means subtract. So x is going to equal half the difference of, it looks like 72 and 35. Okay, so half the difference. So x is going to equal half of 37. And that is going to equal 18.5. All right, and the last one. And the last one here is central angles. Hold on, family drama. The youngin. All right, and the last one is the central angles. Remember, the central is the same as the arc, so x is just equal to 42.5. All right, take a look at the next page here. And we're going to start getting into today's lesson, which is actually finding segment lengths. All right, so there on today's note sheet, we have our three different ways that we can have lines intersecting. Okay, actually there's 4. All right, one of them we already learned was the hat rule. Okay, so 2 tangent lines from the same point outside the circle. These 2 lines are going to be equal to each other. Okay, that's our hat rule. All right, that's number 1. Number 2 is what we're going to talk about right now, which is we have the 2 chords intersecting inside the circle. Okay, so when these chords intersect, they're actually made up of 2 parts. And actually, what they're actually made up of is they're forming 2 different triangles. And these 2 triangles are going to be similar to one another. All right, so what we're going to do is we're going to break them apart and do the part of one chord. So we can see on the first chord, which is the blue one, we do AE times ED is equal to, on the second chord, BE times ED. Okay, or actually this should be EC. EC. All right, BE times EC. So we're just multiplying the 2 parts of the chords together. So segment times segment of the first chord is equal to segment times segment of the second chord. And where this comes from is actually, if you were to connect, okay, we can form these 2 triangles here. All right, and these 2 triangles are actually going to share vertical angles. Okay, so these are equal. And this angle and this angle, B and D, are actually inscribed to the same arc. So they're also equal. Same thing with A and C. So we know that these 2 triangles are going to be similar, and then we can just multiply their corresponding parts together. So we can make a ratio of BE over ED is equal to AE over EC. And then when I cross multiply, notice that I get BE times EC, which is the first segment, equals AE times ED, which is the second segment. So this formula, segment times segment formula, is a shortcut version of doing similar triangles with the ratios here. All right, so let's do that question real quick. So here we go. So in the first one, we can see the 2 parts of the chords. For the first chord here, we have A times B is equal to the second chord, and the two parts here are C times D. Same thing going on over here. This chord is to cut into C times D is equal to the two parts of that chord, which are A times B. All right, drawn this way, same thing, okay? So we have C times D is equal to A times B in that chord. And likewise, in this setup, this chord is intersecting, and we get C times D, okay, is equal to that chord intersecting, and the two parts are A times B. Okay, we're not going to fill in the chart here, so no need to worry. We're just going through and talking about those relationships. All right, in the second one, okay, we have this scenario where we have two tangent lines being drawn. Two secant lines. So anytime we have the secant lines that are intersecting, we get this secant scenario. So on your circle notes, okay, this is our secant times the secant scenario. And so what we're going to talk about is that we are going to multiply, all right, from each secant line, the whole secant line times just the outside segment. Okay, the whole secant times the outside segment. And the same thing on the bottom. The whole secant over here times the outside segment. Okay, and where this comes from, again, is similar triangles. If I were to connect the two chords here, okay, I'm going to form these intersections, all right, and these two triangles are going to be similar because of our drawing a blank here for a second, because of our angle similarity theorem. Okay, so we have, you can see, like, I'm just going to do it in black so you can see it. This angle here is intersecting this arc right there. Okay, and the same thing is occurring from the other angle. Let me piece this together real quick. So we have angle. All right, this one took me a second to put this together. This is not the right triangle here. So hold on. So the way we want to cut up our triangle, all right, is like this. So we want to make our first triangle connecting V to Y and forming this triangle here. Okay, and the second triangle we're going to do is connecting Z to W, forming this triangle here. All right, so we have a congruent angle at X. All right, and then the other angles we have are these two angles are equal because they share the same intersecting arc. So once these two triangles are similar, then we can talk about their corresponding pieces. Okay, so WX in this red triangle is going to correspond to XY in the other triangle, the blue triangle, and then the whole segment, okay, in the red triangle is ZX, and that corresponds to VX in the other triangle. And you can see that as we multiply these together, okay, we get WX times XV, which is this first segment, and then we get ZX times XY, which is in the other segment. So we're doing the whole secant line times the outside segment. That's just a justification. I don't expect you guys to know that one. You don't have to know the justification for it. You just have to kind of know how to use it. So I wanted you to see where it's coming from, but really, for our purposes, it's just a whole secant times the outside segment. All right, so let's go through that in our module book here. So once again, whole secant is A plus B. The outside piece is just A. The whole secant here is C plus D, and the outside is just C. So in this formula, it's going to be A times A plus B is equal to C times C plus D. All right, same situation here. The whole segment is C plus D. Outside piece is just C. Okay, the whole segment here is A plus B, and the outside piece is just A. So C times C plus D is equal to A times A plus B. All right. And then we have the same thing going on for C. So I'll let you guys fill these in, and I'll do them on my own. Okay, so do that real quick. Okay, so here we have, once again, remember when we're thinking secant, this is what we're going to start writing here, okay? Outside times whole equals outside times whole. So the outside is A, the whole is A plus B, okay? A plus B. The outside for the second one is C, and the whole is C plus D. So same thing here. A is the outside, A plus B is the whole, C is the outside, C plus D is the whole. So there's our formula. All right. So same concept here. I'm going to skip through this part, but we know the formula now. Okay. We're only going to talk about this one on the bottom here. So this is a new one we haven't talked about. This is a tangent line and a secant line. Okay. So when you think about whole times outside, this is both the whole and it's also the part that's outside the circle, okay? So we're never going to talk about the part that extends beyond the circle. We're never going to talk about that because our triangles are technically being formed from here, okay? There's your first big triangle, and from here, here's your second triangle, all right? So this angle and these two angles are being shared, and if you remember, this is a tangent chord, and it's equal to this inscribed angle because they're both half of that arc being formed there, okay? So these two triangles are similar again, and then you can just create a ratio of the sides, okay? That's all it is. So the whole, remember what we said, the whole, and actually what we put down first was the outside times the whole equals the outside times the whole. Okay? Now, the shortcut here is that whenever we think tangent, we're really going to think tangent squared because the outside piece, right, is this letter C, and the whole is also just C. It's the whole line, the whole tangent line up until the circle, right? And it's also the piece that's outside the circle. The whole, or the outside piece for the tangent line, or the secant line here, is B, and the whole line is C plus B. So I'm assuming this is actually A. So A times A, and then B plus C. So this becomes A squared, so that's why we can just do tangent squared, equals outside times the whole, B times B plus C. That's our formula. Okay? And it's just coming from these corresponding sides. You can see this side corresponds to this whole side, okay? And this side right here corresponds to the short side right here. And that's it. So our three theorems are, when the secant lines intersect inside the circle, we're doing part times part, or segment times segment inside the circle. When they intersect outside the circle, we're using the outside part times the whole, outside times whole. And if a tangent line and a secant line meet, it's the tangent squared equals the outside part times the whole. And the only other one we talked about, remember, is the hat rule, which means if it's a tangent line and a tangent line, those are equal. All right, let's do some questions. So take a look at number 1. We want to find x. So once again, we're just going to do part times part, or segment times segment here. Okay, so the segment times segment is going to equal the segment times the segment. All right, remember we're using this formula right here. Segment times segment formula, okay? So this first segment is 6 from the same piece, right, is x, is equal from the other chord 4 and 12, 4 times 12. So I get 6x is equal to 48, and divide by 6, and x is going to equal 8. All right, Number 2 is 2 secant lines. So remember, we're doing the outside piece times the whole and outside piece times the whole. So we're kind of rewriting instead of whole times outside. Sounds a little better that way when we say it, but we're going to do the outside piece times the whole. It's kind of how we do it, distributive property as well. And then outside piece times the whole. Okay, so for the first one, outside piece is x, and the whole is 1 plus x. The outside piece here is 2, and the whole is 4 plus 2. You could just put 6 if you really wanted to. So this is going to be x plus x squared is equal to 2 times 6, which is 12. So I get x plus x squared is equal to 12. And remember, as soon as I see x squared, I know it's a quadratic. So I'm going to get the 12 to get this equal to 0. So 0 equals standard form, x squared plus x minus 12. And then if you remember the factors of negative 12, the add or subtract of 1 are negative 3 and 4, where the 4 is positive. So you get a positive x. We're going to do our factors, x minus 3 times x plus 4 is equal to 0. And then we do our zero product property. So if x minus 3 is equal to 0, x is equal to 3. Or if x plus 4 is equal to 0, x is equal to negative 4. Remember, we can't have negative lengths. Okay. So our answer here for x is going to be 3. And then just be careful that the question isn't asking you to figure out what one of the segments is. Okay, so just double check that at the end. All right, we're going to skip number 3. All right, it does say that DF is less than FE. So they said that this is 3. You would just do the same thing, part times part here. So 7 times 6 is equal to 3 times x. All right, 42 is equal to 3x. And then we just divide by 3. I know I said to skip it, but and 14 is equal to x. Okay, this is important to know that when it's not drawn to scale, which one's bigger and smaller. And then the second part, common one, they're just going to give you the numbers and you got to label it. So CE is 6, CB is 9, which means this whole thing is 15. CD, which is the whole segment here, is 18. We want to show that this is 3. So right now we're going to call it x, and we're going to prove that it's 3. So we're going to do the same thing, right? Out times whole equals the out times the whole, because they're secant lines. So 6 times 15 is equal to x times 18. Careful you're not doing x plus 18, so make sure you're careful where you label CD here, okay? And then 6 times 15 is, looks like 90, is equal to 18x. All right, just double checking here. All right, it's really hard to see these numbers, and I realized that this does not make sense. This doesn't work out at all. I went back and looked at the actual module book, and this is actually the 9, not this. So 6 times 9, which makes this 3, which really doesn't make sense. So not drawn to scale there, people. Okay, so this would be 6 times 9 here. Sorry for any confusion here. All right, and then 6 times 9 is 54, and divide that by 18, and we do get 3. All right, and I broke it. So divide by 18, and we're going to get 3 equals x. All right, so same type of questions here. I urge you to try these on your own. We'll do these ones, and then we will stop. So we'll finish up with 5, 6, 7, and we'll do all the way down to 8, okay? So tell you what, try them on your own, see if you can go through and do them. All right, I'm going to pause it here. I'm going to do them all, and then we'll go through and talk about them. All right, just an FYI, you are going to get a radical for 5 and a decimal for 6. So keep that in mind. All right, and here we go. So number 5, the tangent squared equals whole times outside. So the tangent squared here is x, so x squared, and then 4 times the whole thing, which is 13, becomes 52. And we take the square root, we get the square root of 52, which technically would be okay here. It doesn't say simplest radical form, but we are going to do it to it. So we are going to break this down into 4 and 13. So 2 times 2 times 13. We take out our set of 2's to get 2 radical 13. Number 6, our whole is 15. The outside here is 6. The whole is x and the outside is 8. So 6 times 15 equals x times 8. Just divide it by 8 and you get 11.25. All right, number 7 is a quadratic equation here. So the whole here is x. The outside piece is actually the difference of x and 27. And then once again, the whole is 20, the inside is 12, so this is 8. So x minus 27, the outside times the whole, gives us x squared minus 27x. And 8 times 20 is 160. So I notice it's a quadratic, get it equal to 0. And then the numbers that multiply to give me 160 up here, that add or subtract to give me negative 27 would be 5 and 32. So I bust out my factored form, x minus 32 times x plus 5 equals 0. So I get answers of 32 or negative 5. And once again, we are rejecting the 5 because there are no negative lengths. Okay. Number 8, same concept here. This is the tangent line. This is tangent squared. And then the whole times the outside piece, which the whole is x plus 7. Outside is just x. Okay. So x plus 3 squared. Now remember, when we square it, it actually means we multiply it here times itself. So we do x times x, 3 times x, 3 times x, and 3 times 3. So we get x squared plus 6x plus 9, which we're going to bring back into the formula here. And then we distribute to get x squared plus 7x here. So once again, because it's an x squared, we want to get it by itself. And when we do, these cross out. So we really get left with 6x plus 9 equals 7x. And then we subtract away the 6x, and we get x is equal to 9. Now 9 should have clarification here. So let's go through the question first, and we'll talk about the clarification. We can't figure out these based on the work until we know which is bigger, BF or FC. So I label my parts. DE is 11, that's the whole line, okay, from D to E. But DF is 8, so that means FE has to be 3. So we got the first answer, DF is 3. And that means when I do part times part, I'm going to do 8 times 3 for the first chord. The second one, the whole thing is 10, and this piece here, we don't know what it is, but we're going to call this X, okay? Which means the other piece over here has to be 10 minus X. So I do part times part, it's X times 10 minus X here. And then when I distribute through, I'm going to get 24 equals 10x minus x squared. Remember, we want positive x squared here, people. So we're going to add the x squared, subtract the 10x over to the other side to get this quadratic x squared minus 10x plus 24. Now, when you factor, this should be the correct factored form. Negative 6 times negative 4 gives me positive 24 and negative 10. If you try negative 12 and 2, okay, these two numbers, while they do give you negative 10, they don't give you positive 24, they give you negative 24. So this factoring will not work, okay? So my factored form should be x minus 4, x minus 6, and then when I bust out my two solutions, I get 4 or 6 as my answers. So I'm going to tell you is based on the diagram, so I'm telling you right now, it should say this, that BF is smaller than FC. And if that's the case, we know BF is 4 and FC is 6, but we can't answer that question without that information. And that is it for today, guys. Hope you guys have a great Wednesday. 2 review days coming up tomorrow, so I'll have a live stream for those to go over them at 11 as well. Instead of going through the lesson at 11, I will if you want to, but I also just take any questions you guys have. So feel free to join me 11 o'clock. Talk to you guys later.